At IHMC, we are learning a terrain cost map by training our little dog robot on diverse surfaces, allowing it to build up a rich memory of classifications. Each terrain point is locally modeled as a paraboloid characterized by 3 surface parameters: its surface normal and its forward and lateral concavities. Here we see a variety of points plotted in 3D space according to the values of their 3 surface parameters. We train the dog on several diverse terrains, progressively building up a database of good and bad points along with their 3 characteristic parameters. The quality of a terrain point is determined by measuring the distance that the foot slips. We start by walking the little dog on flat ground. The lower left visual shows the raw data being collected. In the lower right, we demonstrate how, as more data is collected, we are able to progressively generalize to an uncharted terrain. We continue training the little dog by gradually pitching the flat terrain at greater and greater angles, thereby increasing the probability of foot slippage. We increase the pitch until we reach a point where the dog can no longer walk. In the visual, we can see that as more slippage occurs, more red cubes are added to the plot. From our database of parameterized good and bad points, we build a lookup table that can be used to predictively score an uncharted terrain board. In this visual, each terrain point was scored by computing the 3 parabolic characteristics and then using the lookup table to estimate slip. We continue learning by walking the little dog across features that have been constructed by fabricating various kinds of rocks to simulate more complex terrains. A more diverse set of points in memory allows the classifier to predict more points on uncharted terrain. Here the board is shown with all the training data used to score it. While this method provides information on local terrain data, it fails to capture large-scale properties such as proximity to drop-offs. When a heuristic drop-off score is added, the final cost map can then be used to choose footsteps in a path planner. Due to unmodeled large-scale features, the dog may fail as shown in the first trial in this video. To account for this, a trial-to-trial learning algorithm remembers bad footsteps and avoids them in future trials, enabling the little dog robot to cross the board after a few attempts.